Hello, welcome to our presentation. This is Cem from Inovasyon Muhendislik, Turkey. I'm R&D engineer in here. Inovasyon Muhendislik is a SME located in Eskişehir, Turkey. Inovasyon Muhendislik carries out R&D technologies in the fields of robotics, indoor positioning, and machine learning. Today, I will present mutation-based software fault injection tool, which is called InFit. In today's industry, robots are critical parts of processes. Robot safety and security plays important role in industrial applications, and safety and security of these robot systems should be verified. For this aim, industrial robots work in every field at the present time. Robots must be safe and secure for production processes. In this way, InFit aims to ensure safety for individuals and production processes. To verify safety of robotic systems, which includes human-robot interaction. InFit provides fault library to make fault injection, and thus InFit increases the robustness of robot softwares. Our main goal in the various project is to reduce the planning and execution time and effort in robotic applications. This target has been established to cover the VMV processes. Software fault is also known as the defect arises when the expected result doesn't match with the actual results. It can also be error, failure, or fault in a computer program. Most bugs arise from mistakes and errors made by developers, architects. Fault injection is a software testing technique by introducing faults into the code for improving the coverage. Fault injection testing usually uses with stresses testing for robustness of the developed software. There are two fault injection approaches. The first one is compile time injections, and the second one is runtime injections. Compile time injection is a fault injection technique where source code is modified to inject minor faults while compiling source code. Whereas in runtime fault injection, there are mutators which are triggered to inject a fault into a software system during runtime. InFit mutates the source code of the sensors and ROS to make fault injection testing. InFit has a special fault library for ROS. The fault library has special Python-based faults to implement for robot sensors and ROS. The users can use this library if they want to fault inject to their robotic softwares. When we look at the past times about the fault injection tools, we could find Safe, Find, TESI, LFI, FIDL, FCI, FastFI. When we examine these software tools, we saw these software tools were created for different software languages and environments. These software tools are made for different software languages, libraries, and operating systems. For example, Find made for Unix, TESI, Safe, and FIDL made for C and C++, LFI made for libraries, etc. When we check a tool for using in ROS environments, we don't take any result. We need to develop a tool which is using for ROS systems. So InFit born like that. InFit purpose is to ensure software of robot operating systems. InFit developed with Python, ROS, and Gazebo, and it provides convenience VMV methods for safety and security. With InFit, developers can analyze robotic systems with less effort and time. They can create more dependable systems before implementing the system in real time. With the popular use of ROS in industrial robotics, this tool will be developed as compatible with ROS and Gazebo. In developing InFit, ROS industrial quality standards are taken into consideration. The goal of InFit is to be compatible with ROS-based robotic softwares. Also, purpose of InFit is to be tailored for tool for robotic systems. According to InFit architecture, this tool consists of three main modules: scan, execution, and monitoring. The main work done in scan module is to scanning the source code. Infit will be customized fault library for ROS. In execution, user creates fault injection plan with selected faults from library and runs fault injection test. After the execution step, Infit analyzes trace and log files information. Next, Infit displays these informations graphically. Also, our objective is to operate Infit with simulation-based testing tool to enable comprehensive verification for robotic systems. SRBT is created by transferring the real-world systems to the simulation environment to carry out test evaluation scenarios. The faults are implemented in Infit is realized in SRBT tool. With SRBT integration, Infit will provide simulation-based fault injection for automatic system. Infit provides safety for robust softwares. Thank you for listening. Please follow Values Project on social media channels to learn more about Values Project.